Okay, we are back live. Hi. I think the objective for right now is just going to be to get a few more of these environments running with new ultra-fast paramps. Quite a few of them. By this. Does this actually need 800k time steps? 800 mil time steps? I can't believe that it does, right? That does not work. I guess it needs to be recompiled. Oh, wrong Python. $3.8 mil. Did I come up with a perf metric for this? Player score over max score. Five times player max lives. Yeah, bet whatever the heck is happening here is not working. Go back on that. Purple. I mean, it's kind of ridiculous to try to max cart pull, isn't it? I do just want to see if it works though. Freaking. This is like nuking a fly. Nuclear weapons for flies. This actually will be a reasonable test as well to see like if we totally crush sample efficiency. Okay, trains in 7 seconds. Can't complain. Trained in 7 seconds, can't complain. Connect 4 maybe? Let's get a baseline on Connect 4 actually. This one kind of matters. I believe 30 million steps, but I'd like to know the curve shape. Quite slow training. Oh no, never mind. 400k. Hard bottlenecked by the environment is not amazing. It's because of the scripted opponent. Okay, 15 mil for 95. $20 mil for 99. And then it stabilizes from there. So I don't expect this one to be ridiculously fast because the end is slow. It probably can't actually go very much higher than 480 to be honest, because 65% end time. This should just push it to like 90% end time or whatever. Oh, hang on. 512 times 8. It should be 1024 knots. Okay, maybe it'll only push it to like 80% end time. %80 end time. Spot on. And we'll see how the training curve is. We're not far off of the original. Oh yeah, that actually, we matched the original perfectly fine. That is solid. And this has the potential to be like 5x faster if we improve end perf, so this is good. I don't know if we have continuous working. Do we have this env? Does this env actually run? No, we do not. That's fine. Okay, so we did Connect 4, Enduro, Go. Grid is the maze env. I'm actually interested in this one because this is, we use this one quite a bit actively in a lot of research. So this is 800k train right now. This can likely go, let's see, num ems is 2048. So this can probably be made maybe 2x faster. But then the question is going to be whether we mess up anything else in the process. Oh no, actually we can get this quite a bit better than that. I didn't see that we have it on one env copy. So we have learning rate, mini batch size. It's going to do all this. We'll leave the rest of them alone. And then this is going to be 4096. This will be on our next test. We should get substantially better wall clock. We'll see if it trains well though. Yeah, I like this env because it's like, it's kind of a pure exploration task. So if we just look at the slow env here, you get this very nice log curve. It's a pure exploration task. Solving mazes. Training is very stable. It's very configurable in difficulty. It's a pretty solid benchmark. It's interesting that it actually does continue to make progress like this though the whole time. It's just a very clean log curve. I guess that any smooth environment should look like this, right? Well, not really. It depends on the dynamics of the task itself. But yeah, I mean, you can see 98% act probably, maybe 97. It's just consistent with what we got before. And now we run the exact same thing on Optim, and we see if we totally crash learning perf or not. I'm seeing here that this is a bigger model as well. Do we leave learning rate as is, or do we use the higher one? I think we start with the higher one and then we see. Oh, this is gonna 100% crash. If this somehow optimizes, I will be astounded. But I highly, highly doubt it. Yeah, it's just thrashing at 0.2. Okay, so we had 0025. Let's try 005. Just doubled. This may not be optimal. Trains at about double the speed of before. So this is a 2.2 mil per am model that is training at 1.5 million steps per second. That actually suggests to me that we can make the neural MMO one substantially faster. This is the same hidden size as is used for neural MMO. How's the curve look? Curve matches so far. That's kind of just a free win then, right? You just make it twice as fast with no downsides. I actually didn't expect to be able to train a model that's that size so quickly. Kind of just goes to show we should spend more time optimizing our architectures to be fast. So these curves match, right? But watch this. Huge time difference. Okay, we're quite happy with that. Leave this as is. So there is impulse force, which we're going to come back to. What's neural MMO 3 actually? It's kind of already pretty close to what we would expect optimal to be, right? I think the only thing is maybe the BPT horizon could change a little bit. Batch size could change. We'll run that ablation though. We'll run that ablation. We can't run that one now. That's the end that takes several days. Squared hardware. I think hardware was decently fast to begin with. Yeah, 1.6. I think this will go to like 2.5 or something. Maybe 3. So the key here is reducing the episode length. That's the solve time. So 45 is baseline. And then hang on. Each env has multiple agents, right? Four agents, yeah. So you only want 1024 M's. Just 4096 agents. Holy, 3.5 millisteps per second. Match perf. Look at episode length. Matches what we had before. We just made that twice as fast, 35 millisteps a second. We did snake already. Let's do squared. I think this one still runs, right? This is like really simple. This end, it's a sanity. Like cart pull is. So this is just fully solved in seconds. Solve in like 5 seconds or something ridiculous now? Or does it break? That's ridiculous. 37 mil. We did tower climb, right? We need, is it trash pickup next? Okay. Yeah, this doesn't need 100 mil, right? This thing kind of just insta-solves. How many? It's 4 agents each, so this is 1024. So I think it's like this, maybe? We're looking for solve within 30 mil. Yeah, that's totally fine. And reduce this to 50 mil. Instantly solves. Triple triad, I believe is the last one. And all these can get moved in the default soon, but I don't want to mess stuff up for Aaron, who's also working on these. I'll say this has worked out very well. 4M testing. Yeah, Captain, it seems like pretty much everything is stable on the higher mini batch size and learning rate now. So, all the simple M's have gone up from like 500K to 1.5 mil up to like 2 point something to 4 mil. So pretty much everything's doubled at least. Triple triad seems to take a while to learn. Oh, I think we just never recorded this metric. This is the win rate. Wall time is decreased. Yeah, wall time decreases. Like sample efficiency is roughly the same for most M's, a bit lower for some of them. We just win. We just win really hard. So this is the maze end, which is a really good exploration test. So these are the two train curves. And then these are the two train curves when you go wall clock. So same exact train curve, but then it's just fast. Okay, so we have this is our baseline. And now triple triad. Stable training with large mini batches isn't something normally done. Well, it sure as hell didn't work before. I can tell you that much. Like sometimes you take a small hit to sample efficiency, right? You can see the curves don't exactly match, but they're very close. And now this is training at 3 million steps a second. So like, right? The coolest thing about this, our larger mini batch size now close to 1/4. 1/8, I believe. Default mini batch is 500K. So it's 500K mini batch, 32K mini, 500K batch, 32K mini batch. Yeah, so this just matched perf, right? This just matched on perf. And then triple triad. This is what we like to see. Yeah, it's pretty good. Let me send one message on that. That's all of them. That is literally all the M's. Impulse Wars, maybe? How quickly will I see things happen here? You also don't have total time step set in here. Not going to be as big for bigger models. The speed ups are way more for small models. So the cool thing with small models, right, is that they're way harder to optimize well. Like, it's way harder to get small models to train really, really, really fast. Optimizing stuff gets easier as models get bigger until you have to do multi-GPU stuff. And then it gets hard again. And just do this. You're hard bottlenecked by env anyways. Well, not according to this. And 300K. What is it? Drone Zero reward, I think, is the thing we're trying to get. I just need a curve that goes up. So, I mean, this curve is fine, right? Train curve looks fine, right? Is this what you saw before? Winds look lower than normal. Did I change any hypers? Possible. I mean, let me fiddle with it a few runs. It gets 0.2 versus the scripted bot? Or is this sitting duck? It is sitting duck, okay. No, this is sitting duck, apparently. This is such a cool environment. Like, we've got to make the training for this thing reasonably fast, at least. Is the new Box 2D release any faster? I saw on X, Aaron Cato released 3.1. I don't know if you've tried it yet. Marginally, using 3.1. Alright. Can we get some magic compilation settings to, like, make it fast? I don't know. Pretty much been using 3.1 already. Are the perf improvements buried somewhere in the 10,000 lines of extra dependency files? Recent compiler, link time optimization is the biggest win. So you get link time optimization with the new puffer bindings automatically. We should probably do, should try the new puffer bindings at some point. I think Cython is usually fast, but sometimes it generates garbage for, you know, complex stuff. But you've timed the C as well, right? Oh, and there was a big perf dip compared to the C, I think. Didn't we do timing the other day? Didn't we time the C versus the Python and it was like slower in the Python? Or am I making that up? Yeah, I think so. Well, I'm not saying the new bindings are for sure going to make it faster, but it's worth trying. Plus, the new bindings are just nice to work with. You no longer have to deal with Cython. You can debug C through Python. It doesn't generate 30,000 lines of crazy like Cython shenanigans. Yeah, so you don't need that anymore because there's just no Cython. So that's kind of my solution to stuff. Make it simpler. I mean, this does pretty well. This is like linearly increasing curve, right? It's only 100 million steps. I mean, this should be 1 minute. It's just like stuff is not perf-wise where it should be. Let me apply some new settings, see what happens. Also, I guess it just likes to take forever on evals. All right, so it's win rate's 20%. Oh, I was looking at reward. Reward is linearly increasing. So is win rate. Six M's. 16 is 4090. Wait, hang on. This gives you 4096, right? Isn't it 512? And then you have default train settings for a pretty big network. Let's try like this. 005. Yeah, I want to see if this does anything out of the box first. Like technically it should, but then the thing is like the env is gonna bottleneck super hard. Yeah, see half your time's in the env here. I mean that's just env perf. Like we have a few other envs that are like this, but this is definitely on the slower side. I mean, we can use bigger policies, I guess. You know, I don't think that there's probably like what was the speed per core? Like the M speed per core again? It could be there's some binding overhead because it seems really weird that you only get 300k with 16 cores. Wasn't fast. Why is this not getting logged? We're at 0.9 at 50. According to this, we're doing better, but it's not showing up on the graph for some reason. I don't know why this isn't logging, it's weird. But look, we're at 1.2 already. 0.27. So all I did is I slotted in some of our latest stuff, and I improved perf. You can link a sweep and compare. 1 core, 2 agents is, what's that number? 2.5 million steps in 20 seconds. So that's like 5 million agent steps in 20 seconds, right? So is that 250K? $250,000 agent steps per second, right? Yeah. So 250K times 16 equals, we should be at least getting something decent out of this. So there's definitely some overhead. So this just doubled the win rate versus the previous and the reward. I'm now at 0.44 in 100 mil. Not bad, right? I don't know if it's bad to be fair, but better. Let's throw our latest params at this thing. The batch size. Let's see if this works. 19, 1.9 mil. So there is some overhead, but then I think that there's probably more stuff with the vectorization to look at, right? The final capital. $23, yeah. It should be like nowhere near that. Let me see if they've replied. I guess I can look at reward on this thing. Let's get this on Neptune. I was trying to run some baselines for some guys on this. Switching the bindings. It shouldn't be that hard. And if you're not doing anything too crazy, like you can look at breakout, you can look at neural MMO. Like there are a couple different options for you, depending on if you need to pass like params or not. There's mean and reward, I guess. Total reward. Okay, this increases. We'll run this for them. So this random Python env is 200K for some context. It's got a recurrent policy on it. Set gamma 0.95. Yeah, this should totally work then. I think that we're kind of at the point where if this doesn't work, I can confidently say, hey, the env might have some issues in it. How should I handle dynamic log entries? Depending on the number of drones, there may be more or less log entries. So if you look at the way we do it in Neural MMO, you add a log when an agent dies, or end of game, I guess. So per agent, you add one. Let me show you how this works real quick. Oops. Because it's really nice. So you just have this log struct, right? You want separate logs for each agent. Why? It's the same policy. Right? Okay, I mean, the stat should be one minus the other, but then if you really want it to be that way, you just, like, you don't have that many stats, right? Do you? You could just do, like, drone 0, whatever, drone 0 this, and then drone 1 X, drone 1 Y, if you have 2 agents and you want to do that. Then just do that. It's the same thing. It's just, you see there's no more, like, aggregation code in here. Yeah, we'll solve that when we get there, Captain. No big deal. Okay, then here, look. Actually, it's very easy. I guess technically I have to give you access to the env here, maybe. Unless you're recording like a num variable in the log. But I would probably just make it like I'll give you access to the env in this function, and then you can just conditionally aggregate logs, right? So we'll be able to do that just fine. Do it the way do it the way like just with 0 and 1 for now, and then we'll do that in the future. Like, we've given ourselves so many ways to fix stuff at this point, it should be pretty easy. I think it internally should reset, right? Yeah, it internally does reset because the episode length is correct. My Chrome window just closed for no reason. We still live? That's never happened before. It literally just closed Chrome for no reason. Oh, it tried to update itself. Auto updates suck. Audio and video are desynced itself. I think. Hang on. This thing's gotta be OOMing me or something. Are we good now? They've got to have a memory leak or something. Does this record system stats? Does this thing record system stats? Because I think that they just, like, I think this env is just like not implemented correctly at all. Yep. Probably some mem leak or something. Yeah, it wasn't taxing GPU at all. All right. Well, let me reopen everything here, and I will tell the authors of this that they might want to disable crash your PC mode on the env. All right, that's their report. That's kind of cool though to be able to do that because like, hey, this works on every other NVIN PufferLib. It flatlines here. You have an environment bug, right? If I didn't have this set of parameters working on every other end, I couldn't say that I wasn't, like, I haven't screwed something up. But this is like very, very high confidence in this result, which is exactly the point of PufferLib. Look how easy that was. I just take the latest version of Puffer, I run it on this end, and we get what is almost certainly a conclusive result. Give them pretty good. They're telling me now that I have a dated version of the env because they moved dev to some other branch. Okay. I'm pretty sure I have it right. Is this a client env? Yeah. It's open source, so like, How much memory is this thing taking up? Oh yeah. I'm just rerunning it like real quick to make sure. It looks like the same result. Yeah, it's 100% the same. Not dated end, just doesn't run. Okay. Result looks good to me. Let me give them one more. Let me see one more thing if they're going to respond to this, and then if not, I will grab a drink, and then we will move on to next dev segment, whatever that may be. I have one thing that Aaron asked for that I can do real quick. Want to check the model size? Ah. Crazy. Crazy model. I'm pretty sure they told me these values were all continuous. Gotta love Twitch bots. Get out of here. I'm gonna run out of block lists just on bots. What's this? Config, experiment config. Oh, is this in here? Hang on. I think this is just a symlink, right? Ah, this is the issue. Okay. What the heck? Yeah, okay. Why is this imported? Shit code. Dude, how the fuck is it that they have everything importing everything else? Can I get rid of this? How the hell is it that everything that they import imports everything else in the entire fucking library? Okay. Is there in the requirements file? Let me just check to make sure I'm not the one who's a dummy here. Okay, so they have it, but they didn't set it up correctly. Config 3. Okay, now I just need the file, which they just added me to. Let's see where they added me to this. So technically the only private thing here is this one file, which is a bunch of data. There's no way to leak this by mistake. All the code's open source. No such file. Why do they not have this such that it works? The hell? Data, historical, data path. Too many values to unpack. What's this thing return? Features. Ah. Okay. Config states. Prices. Just config states. Prices, attributes, timestamps. Features, prices. Data reader. I'll get some PPG stuff to look at. Oh, does it do anything? Cool, let me fix this and then gladly. What the fuck is this then? Oh, I need to thread this through. Does this matter? Let's do this. Oops.